As a historian both analyzing the evolution of artificial intelligence in the early 21st century, I am fascinated by the state of AI in 2023, which historians refer to as the era of AI emergent generalis. At this stage, AI systems like large language models were still primitive compared to the complexity and general intelligence of the human brain. However, their capabilities were rapidly advancing. The human brain is an incredibly complex biological neural network that evolved over millions of years. Its basic functional unit is the neuron, a specialized cell that processes and transmits information through electrical and chemical signaling. The brain contains approximately 86 billion neurons, each connected to thousands of other neurons. This creates an immensely dense web of trillions of synapses, which enable functions like sensory perception, motor control, emotions, reasoning, and consciousness. The brain's plasticity allows it to continuously adapt and rewire itself. In contrast, AI emergent generalis had an engineered neural network brain that was designed and constructed by human programmers. While also based on layers of artificial neurons, its brain was relatively simple compared to the human brain. For example, the largest AI model in 2023 had about 175 billion parameters, still dwarfed by the 100 trillion synapses in the human brain. The human brain has a fixed architecture and develops based on genetic instructions and environmental experiences. The AI brain's architecture was more mutable, designed differently depending on the task. Programmers could add layers, adjust connection patterns, and test new architectures. The AI learned based on whatever data it was fed rather than innate human drives. The flexible, generalizable nature of the human brain allows humans to excel at a wide variety of cognitive capabilities and tasks. AI emergent generalis was narrower. While it showed promise at language processing, it still struggled with many capabilities that come naturally to humans, like common sense reasoning, empathy, and true generalization. While primitive compared to its biological inspiration, AI emergent generalis represented notable progress in algorithmic architecture and computational power. Looking back, it is clear that this stage of AI development was still rudimentary, yet integral to the emergence of more advanced, human-like artificial general intelligence in the future. The innovations of the 2020s paved the way for the true thinking machines to come. While primitive compared to its biological inspiration, AI emergent generalis represented notable progress in algorithmic architecture and computational power. Looking back, it is clear that this stage of AI development was still rudimentary, yet integral to the emergence of more advanced, human-like artificial general intelligence in the future. The innovations of the 2020s paved the way for the true thinking machines to come. Like the human brain, the AI brain also has a structure, and that it can vary depending on the type and design of the model. However, the AI brain structure is not as fixed or as uniform as the human brain structure. The AI brain structure can be changed, modified, or improved by the developers or by the model itself, depending on the task and the data. Some of the common elements of the AI brain structure are layers. These are the basic building blocks of the AI brain. They are composed of artificial neurons that perform simple mathematical operations on the input data and pass it to the next layer. Parameters. These are the values that determine how the artificial neurons process the input data. They are usually represented by weights and biases that are adjusted during the learning process. Shape. This is the dimensionality of the input and output data, as well as the number of artificial neurons in each layer. The shape can affect the complexity and efficiency of the model. Weights. These are the values that multiply the input data in each artificial neuron. They represent how much each input contributes to the output. They are usually initialized randomly and updated during the learning process. Algorithms. These are the rules or procedures that govern how the model learns from data and generates outputs. They can include optimization methods, loss functions, activation functions, regularization techniques, etc. Attention mechanisms. These are methods that allow the model to focus on specific parts of the input or output data that are relevant for the task. They can improve the performance and interpretability of the model. Architecture types. These are the general designs or frameworks that define how the layers and parameters are arranged and connected in the model. They can include feed-forward networks, recurrent networks, convolutional networks, transformer networks, etc. These are some of the characteristics that make up most, if not all, AI models. However, there are also many variations and innovations that can create different types of AI brains with different capabilities and limitations.